Today's lesson is on 4.2, which is reflections. So this is basically the second transformation. So reflections is the second transformation. So remember, transformation is the overall title of the chapter. So this is like the big umbrella. And then what we're doing is we're kind of showing you 4 different types of transformations. So in the first lesson, we did translations, which is basically a slide. You're going to move it left to right. Today's one, so this second one, is a reflection. And then the next lesson will be rotations, and then the next lesson will be dilations. So again, you can kind of see how they fit underneath the bigger heading. And so basically what you're going to do is you're going to be reflecting in a coordinate plane. Now, there are reflections that are not in the coordinate plane, and if we have time at the end of the trimester, we're going to do some of those. But we need to make sure that we're completing what we kind of call the state guidelines or the state standards. And so if we have time, we'll do some other ones, but we need to make sure we get these ones in first, okay? So everything that you're going to be seeing in this chapter is going to be ordered pairs because they want you to do it on a coordinate plane. And so if we look at number 1, they want us to graph this triangle, and then they want us to reflect it over the x-axis. And then they want us to see what happens. So let's go ahead and graph this. Now again, we don't really care what kind of triangle this makes, whether it makes a right triangle, obtuse, we don't care about that. We just need to see the triangle. So we've got the triangle graphed, and now it wants us to reflect over the x-axis. So here is the x-axis, and basically what they want you to envision is if you could take your piece of paper and fold it perfectly on the line. So if you folded it perfectly, where would this fall? Okay, so if I were to take this again and increase my paper, they're stapled together, so it's a little hard to go top down. But if I were to fold this paper, where would it land? Well, C would land straight right here. That would be the new location of C. B would land right here. And A would go straight to here. Now, if we were in class, again, I would be having you fold your paper and kind of see if you could see through. But what I'm kind of trying to show you, or I want you to notice, is the distance that B is away. So this distance right here, whatever that distance is, so this distance is 2, it's going to go 2 in this direction. Because remember, distance is preserved. Same thing goes if you do C. C is only 1 away, so then you go 1 this direction. And then you do the same thing with A. A is 3 away, so then you go 3 this direction. So this would be our new location. So let's write down those coordinates. So we've got A's new coordinate, B's new coordinate, and C's new coordinate. All right? So now I want you to do kind of the same concept here, only we're going to reflect it over the y-axis. So you got to graph the original triangle again. Notice it's the exact same triangle. So here's the same triangle. Now instead of folding it down, we've got to fold our paper across this way. So we're folding it over. But again, I want you to think about the same concept. In this one, A is only 1 unit. So then we have to go 1 unit this way. So here's our new A. Now look at B. B is 5 units, so we have to go 5 units this way. And look at C. C is 2 units, so we're going to go 2 units this to the left. Okay? And so let's write our new coordinates down. All right. And so this works. You can do this for every single problem. You're just going to have to get out graph paper to draw them out. So they're kind of hoping that after you do this, notice it says observe, to kind of see if you could maybe come up with a rule. Okay, so let me write down A, the original A here, and then the original B, and the original C. So these were the original points, and I want you just to kind of take a quick look and see if you notice what is changing. And so if we were in class, I hope you would be telling me that the y coordinate is the one that changed. And so here in a second, we're going to be writing down a rule, so you can kind of see on this side, or it says shortcuts, rules or shortcuts, for how to do these so we don't have to graph them every single time. Okay, but we're just kind of trying to come up with a pattern here. So we're noticing that the y coordinate changed, but the x didn't. So sometimes they like to write it like this. So basically you're doing the opposite of whatever the y is. All right, let's do the same thing for this one. And you might be able to even notice the pattern after I just write down a couple of the originals. Now notice I'm just copying the originals straight down again. So these are just the originals. So notice in this case, the y doesn't change, but do you see how the x changes? So oftentimes what you'll see on this one is you'll see them say opposite x, comma, y. So you change the x coordinate, okay? So these are two really common ones that you'll often see. Then there's two other rules that they will sometimes give you as well. And I'm just getting out a piece of graph paper here so that you can see me kind of graph it. So what I'm going to do is I'm just going to graph these ordered pairs instead of trying to do a full-on triangle because it can get a little complicated. So I'm just graphing 1, 4. So this is point A. And now it says reflect over this line. Now this line goes right through the origin. So if I start at 0, because technically there's a plus 0 there. So if I start at the origin and then I go up 1, up 1, up 1, up, you know what I mean? This is the slope. I'm going to draw my line. I don't have a ruler here. I'm just going to use sticky notes to kind of connect them straight as best I can. And now what I'm going to do is I'm going to crease it. I'm going to fold it on this paper, or on this line the best I can. I think I've actually creased it pretty good. And what I'm going to do is I'm going to push down on this A. Hope that it will leave a mark on the other side. I'm pushing down really hard. And then watch when I turn it. Do you see how it left a mark right there? So this would be if I were to take and I were to reflect A over the line. This would be its new location. And if you look at my point, it would be 4, 1. So we'll write that down. So once again, they're going to try to see if you can observe a pattern here. So just based on the first to the second, you might be kind of noticing. But let's try one more. Let's try 0, -3. So 0, -3 is right here. So this is point B. Now again, I'm going to fold it, but now I'm going to have to fold it like this way so that I can press down on the other side. So I'm going to fold it, and I'm going to press down as hard as I can. Hopefully it'll get some ink onto the other side, or at least maybe even make just an indent. Notice when I unfold it back, do you see the location? So now this is my new B. So my new B becomes -3, 0. So again, if you just kind of observe this pattern, if we were in class, I'd probably call on one of you and ask you what it is, but do you notice how they're just switching the X and the Y? They don't do the opposite. So if it's negative, it stays negative. And if it's positive, it stays positive. Obviously, 0 isn't positive or negative. It's neutral. But basically what you're doing is you're just switching the positions of the two coordinates, okay? So we've got 3 rules, and now let's look at the 4th rule. Now this is practically the same line. So if you look, see how it's y equals x and y equals negative x? The only thing that's different now is this line is going to go in the opposite direction. So I have another graph down here that I'll use for you just to kind of observe. So let me graph this. So 2, 1 is A. And now this line, again, is going through the origin, so it starts at 0, but my slope is negative 1. So I have to go down 1 over 1, or I can go up 1 over 1, but I have to go in this negative direction. So let me just connect these. So this is my line, y equals negative x. That's just the line that I'm folding it over. So I'm going to try to crease it onto this line the best I can. Trying to fold it pretty much right on that line. Crease it nice and good here. So you can see that that's all I've done. I just put a crease there. Now, I'm going to fold this over because I'm going to reflect it over the line. So if I reflect this over, and if I push down on A again, when I open it back up, here's my new location of A. So my new location, if I look at that, it's negative 1, negative 2. So based on what we've been seeing and the patterns that we've been noticing here, each pattern is a little different, but yet they're kind of related too. So see if you can apply what pattern you think this is to an answer down here, and I'll go ahead and graph it out while you're guessing your answer. So try to make your guess. And so my new location is 0, positive 4. Now remember, 0 is a unique one. 0 is not positive or negative. So up here, how the 2 became negative and the 1 became negative, and up here, or down in this one, notice the negative got taken away. 0 is 0, so it's just neutral. So again, what are you noticing about this? Well, I'm noticing that we're not only switching the x and the y, but we're switching and doing the opposite of x and y. So we're doing 2 in this one. So we're making the y first and the x second. So we're switching them, but we're also doing the opposite. Now again, remember, if it was negative, the opposite would be positive. You can't go do it like a double negative. I mean, cancels itself out. So that's what you want to kind of think about here. So these rules that we just wrote down, so kind of this part, this, and this. These are what I would call like your 4 rules or shortcuts. Now, if you don't want to memorize these, you don't have to. However, if you were then on a quiz or test, you would probably need to get out graph paper, because typically what they're going to do to you is they're going to give you a point. Like let's say they say R is 1, negative 3. And then they'll say reflect over, and then they'll tell you something. So they might say y equals x. They might say the y-axis. They're going to tell you some type of a line. So let's say they tell you this one, y equals x. Well, if you know this rule right here, that all you have to do is switch them, then you could just say negative 3, 1, and you're done. But if you don't know the rule, then you're probably going to need to get out a piece of graph paper and graph it out. So I'm fine with either way. I'm just kind of telling you what is going to happen. So if you turn to the next page here, these are sort of the 4 from the other page just in one table. So we've got the x-axis, the y-axis, the diagonal, and the negative. Now, this is copied out of your book, and your book likes to use the A and the B. I think that's a little confusing. So if you want to kind of replace these with X comma Y, to me that makes more sense than A and B. But again, I'm not the author of your book. So if you look in your book, that's the difference. So if we take the X axis, we said we switch the Y coordinate. So we just change the Y. If we're doing the Y axis, we change the X. So I always just remember it's the opposite. When you do the diagonal line, you just reverse them. So the Y comes first. When you do the negative, not only do you switch them, so you also do this, but then you do opposite. So opposite Y, opposite X. So it's kind of a combination. So again, these are just kind of like they're like rules and shortcuts. I'm not saying you have to memorize them, but I am saying if you do memorize them, it does make it go a little bit faster, okay? So if we were looking at number 5, notice they're giving us this diagonal line. So we can either envision going, straight across, so it goes straight across, or we could just take the coordinates of A. So if I take the coordinates, which is -3, 2, then for this rule, all I have to do is switch them. So it would become 2, -3. So 2, -3. This would become my new A. Now, I'm not saying you have to write these down. If you can do them in your head, that's fine too. I'm just writing them down so that you can follow along. So if I were to take B, which is -1, 2, then you switch them to -1. And honestly, once you get a couple of the points, you can probably just count, because this is a 2 by 2 square, so you could kind of just count. You just have to make sure, does the square go this way or does the square go this way? So you just have to make sure you're going in the right direction. But I'll go ahead and do, how about I'll do C. So C would be -1. I'm just getting the coordinates, and I'm going to switch them. So 4, -1. Now, notice once I have C, I know D has to be right here because it's a square, and the distances are preserved. So here's my new location. Notice my B and my A, I kind of drew over top. That's okay. I mean, again, sometimes that happens. It's not a big deal. Just draw it out, okay? So basically, you could be asked any one of these 4 from above. They're just picking one right now so that we're not burning up too much time, okay? But any one of these, x-axis, y-axis, or even the negative. Any one of these could have been in this location. All right, this one I wanted to make sure we went over because if you notice, this is not one of these 4, okay? So these 4 are just specific ones. Now notice where this is at. So if we go x is equal to -2, now the one thing I don't like about this graph is by ones. So notice like 1, 2, 3, 4. This graph is by twos, 2, 4, 6, 8. Super weird, don't understand why, is what it is. Here's x equals -2. Okay, so that's x equals -2. Now what we basically have to do is we have to take this, what would it be, kind of a trapezoid? I don't know, let's call it a quadrilateral. We take this quadrilateral and we're going to fold it across. Now if you want to do that like I showed you with these ones, we could, okay? We could crease our paper the best we can, and we could try to trace on the back side. Or, because this is also a rigid motion, we could just count. So it doesn't matter what one you start with. Like let's say you start at D. Now be careful because these boxes are technically 2, but if you just want to do like one solid box, like right here, like this is 1.5 solid boxes. So I'm just doing D right here. So it's 1 solid and 1/2 of a box. So if I do the same thing, 1 solid and 1/2 of a box, then D is going to land right there. So sometimes I think it's easier with this one to just kind of count it out like we did to get the rules. So if I look at, I'm going to skip, how about we do A next just to kind of get the idea. Do you see how A is 2 solid boxes away? Let's go this way. 1, 2 solid boxes. Here's my A. Now B is a little tricky because again, notice 1, B is not on a line, and 2, it's kind of floating. So just do the best you can. So if we count here, we've got 1, 2, 3 and what, about a half? About 3.5 boxes. So we got to go. I'm going to take a pencil. I'm just going to lightly draw myself a line. So if you can see, there's a very light line that I just drew across here just so I can be straight. So, okay, I already forgot. 1, 2, 3, and about a half. So 1, 2. Now notice I'm going from the line. 1, 2, 3, and about a half. There's my new B. And I do the same thing with C. So if you want to draw a line in, you can. This one's not too bad because this isn't as far. 1, 2 boxes, it's just halfway up. So 1, 2 boxes, about halfway up. There's my C. And here's my new one. Maybe I should put D on this side so you can see it better. That's what happens when you write in pen sometimes. If you put the letter in the wrong place, you can't erase it. But if we were to take our paper and we were to fold it over, the two would land on top of each other. So I guess what I'm telling you here is if they give you one of your 4 rules, you could write down the coordinates and switch them. If it's not one of your 4 rules, then you're better off just drawing it out and counting. Just remember that the distance is preserved. So however far it is from here to here, it's going to be the same distance this way. Okay, so it's always preserved. And that will keep your angles. You won't even have to worry about the degree of this angle, and then the angle just will naturally fall into place, okay? All right, now, a glide. A glide is a very specific, it's a very specific combination. You don't really have to worry about the word glide. Sometimes they'll just use it in the direction. So do you notice down here it says graph this triangle and its image after the glide. This is simply telling you it's 2 specific movements. So the specific combination of a translation, then a reflection. A glide always goes in this order, which again, sometimes I even forget sometimes exactly what the glide is, but it's not a big deal because they always tell you the 2. You do have to go in order. So even though you might like this one to do first, you have to go first and second. Sometimes the order won't matter depending on the combination, especially when there's zeros involved. A lot of times it won't matter. But if this would have been like a +2, then it would matter. So I always just say go in order and it won't mess you up. So the first thing, one thing I'm going to do is I'm going to graph the original. I'm going to wait to label that just so that my letters don't get in the way. Okay, so this is C, B, and A. Sometimes when I put the letters down, then my lines end up going on top of them, so sometimes I just wait. Basically, what they want you to do is they want you to take this triangle, they want you to slide it, then they want you to reflect. So I can go ahead and draw out the second image, so I could count this out. So 1, 2, 3, 4, 5, 6. Here's my new A. I could count this out, and then I could reflect it down. So then I would take this, and I would go down 2. So here's my final location. So I can either, 1, I can count on the graph. Or 2, I can do the coordinates off to the side. And if we were in class, I would ask you guys what you would want me to do. Some of you might like the counting piece. Some of you might like writing them down. So since I already did the counting piece, I'm going to go ahead and do the coordinate for B. So if I take B, I'm going to do this to it. So I'm going to go 6 minus 6, which is 0. Then 3 doesn't do anything. Then I'm going to reflect over the x-axis. And based on the rule up here, the x-axis basically just does the opposite of y. So B is going to become 0, -3. That's going to be my final location for B, 0, -3. So again, you can either count it on the graph, so you're going to move 6 and then reflect, or you can do the coordinates. It doesn't really matter. I'm going to go back to counting just so you can see the example. So I'm going to count from this point right here. I'm going to go 6 to the left, and I don't go any down. So here's this part. That's the C right there. And then I'm going to reflect. So it's going to go right here. And again, you can kind of see my A was a little bit in the way, but that's okay. And there's my new location. So I've got my pre-image and I've got my image. This one in between, I could erase. I don't really need that one. That's just how to help you get here. So it's first and third, because this is really the second one, okay? So again, you've got 2 different ways that you can do that, and it's totally up to you how you would want to make that work, okay? All right. The last piece of this lesson, it's kind of in a strange location. Not really sure why they throw it in here. It's good to get it in the chapter, but it's kind of a weird place that they put it, is being symmetrical or symmetry, okay? So I think everybody knows what symmetry is, and if I was there with you in class, I would ask you. And so symmetry is when you have 2 equal parts. So, you know, if you could draw a perfect heart, which I'm sure I cannot. Okay, if you could draw a perfect heart and you could cut it in half. So you probably remember as a kid, you know, your teacher might have made you take a piece of paper and fold it, and then you would draw half of a heart, and then you would cut this out, and then obviously you would open it up and it would be a full heart. So that's what symmetry is the 2 equal pieces. Now, a line of symmetry, or line symmetry instead of line of symmetry, because they're so similar. Line symmetry is just basically saying when you can fold a figure onto itself. Because there are different types of symmetry, okay? There is symmetry that can be folded, like for instance, this one is symmetry that can be folded. But if you take something like the recycle sign, which gosh, I'm probably not going to be able to draw that very well, but you know how it has like the arrows? Something like this, and then there's like another arrow. You can tell I was never a good artist. So the recycling symbol, if you think about that, you could not fold this. If you tried to cut it and you tried to fold it, it wouldn't work. But you could rotate it, right? So there's different types of symmetry. So this right here is a type of symmetry. Now in our class, we're only going to go over 2 types. So we're just going to do 2. But there's more than 2 types of symmetry in the world. It's just, again, they're trying to give you a basic idea of what this is, okay? So line symmetry is, I would say, probably the most important word on this. You already kind of know what symmetry is, but this is line symmetry. Now, what is the line of symmetry? So notice they put the word of there. So the line of symmetry is the physical line where the figure folds. Now, oftentimes, I don't necessarily care about the line of symmetry. A lot of times they'll draw it on there just as a visual. What I really need to know here is identifying the number of lines. So I don't care if you actually draw them on or not, but I need to know how many. And if it does not have symmetry, then you can just say none or 0, okay? So this is a pentagon. Clearly, if we split a pentagon right in half, notice I could fold it right there, and it would match up. But there's more ways. What if I cut it right here? That would also fold. That would also match up. What about this one? What about this one? And what about this one? Now be careful if you're going to count these because it's easy to double count a line. So I have 1, 2, 3, 4, 5. This line I already counted. This line I already counted. So a pentagon has 5 lines of symmetry. Now again, I don't care if you actually physically draw the lines in, but I need to know the number for each one of these. So why don't you pause it here and try these remaining 5 questions. Okay, hopefully you tried it. So wow would have 1. If you cut it right here, it would have 1 line of symmetry. A rectangle, 1, 2. A rectangle has 2. Now sometimes people will try to say 4. Okay, be very careful. If you go corner to corner, okay, so if you were to go corner to corner, if you were to fold your paper across, do you see this corner right here? Okay, I'm going to darken this corner on the other side. So I'm going to fold my paper, and I can see it right here. So that's this corner. Pushing down as hard as I can. I can kind of see it right there. This corner did not match up to this corner. Now, if this was a square, then I would say 4, but a rectangle only has 2. How about the hexagon? Hexagons have 6. Basically, you go through, yes, you go through here, that's the first and the second, and then you go corner to corners. So there's 3 and there's 4. But now you also have to go through the middle of the sides. So then there's 5 and then there's 6. So it does have 6. Now, kid, I would either give you 0 or I would give you 1 because depending on how you want to argue this K, if you don't use the right font, the kind of where they connect right in here, so I would either say 0 or I would say 1 depending. But if you could, it would be right across, whoop, that's not quite halfway. But if you could find the halfway point and go right through the halfway point and then you could fold it down, that would work. But again, depending on the font that's used on the K. All right, and then this next one is what? Also a hexagon. So notice, 6. So 6 and 6, but notice how they look different. So in number 17, even though it's a hexagon, it's only 2 because you could do vertical and you could do horizontal. You would not be able to do corner to corner on this one because when you fold this over, it wouldn't match up. So this one only has 2. Now, the very last question is more just of an application question, probably not necessarily going to be something that you're tested on, but I think it's very interesting, okay? So it says that you're placing a power strip along a wall that connects the 2 computers. Where should you place the power strip to minimize, so here's the key word, minimize the length of the connecting cables. So let's just put a point on each one of these because we have to use an actual dot. So if we put a dot here and we put a dot there, kind of like at the base of the computer, even though nobody really has desktops anymore, what they're saying is where should I put the connector? So like, should I put the connector here so that way when I plug this computer in and I plug this computer in, that I use the least amount of cable? If I put it here, would this be the least, or should I put it here? Where would the least amount be? The easiest way to do this without guessing is to simply reflect one of them. Now again, it would be easier if we had a ruler. So what you do is you pick A or B. I'm going to pick B because it's a shorter distance away from the line. If I pick A, it's just a longer distance. So where this dot is to the line right here, I need to reflect it straight the other way. Okay, so I'm going to put my dot right here with my pencil. I'm kind of putting some pencil shavings on there. I'm going to try to crease my line here. Okay, so I creased it. I'm going to fold it over and see if I can kind of see through. It's a little hard with that computer, so dark. I think I've got it right there. Okay, so do you see how it left a little mark? Which means then that this has been reflected over the line. It's, excuse me, it's almost like I just did a reflection over the x-axis, only I just don't have any coordinates. So do you see how they're kind of making the connection? They're trying to give you a real life example without a graph, but yet it still has the x-axis feel to it. Now, with a straight edge, you would connect the other computer to your reflection point. So you would connect it like that. Where this hits is your answer. That would be the place you would want to put your connector to minimize your cables. Now you might be saying, gosh, that doesn't look right because this looks awfully long. I promise you, if you were to measure this distance and this distance, and you add these two together, so if you measure their distances and you add them together, whatever that distance is, if you move this orange dot to a different location, I promise you, it would be longer. It works. It's kind of interesting how it works. Now, you might also be saying, well, what if I didn't pick computer B to reflect? What if I picked A? Okay, let me just quick show you. I'm going to put some pencil shavings on here. I'm going to fold. I think I can see it. All right, so see my dot? Watch if I connect computer B. It's the exact same location. So it doesn't matter which one you pick first. Doesn't make any difference. You can pick whichever one. I usually just pick the shorter one because then I maybe don't make a mistake. But this distance right here is the same here. Okay? And then you just do opposite. So you're not going to see a number 18 because in this chapter, they want you to do pretty much everything with what I would call geometric shapes, or they want you to do them on coordinate planes. So they're going to give you like ordered pairs. But I think it's good for you to see a true life example about this. And so if we get done with the chapter in time, like at the end of the trimester or whenever, let's say we have an early release day, we're going to try to do some more of these questions that are not on coordinate planes. But that concludes the second lesson.